Hello students, today we will continue with the revision videos based on ray optics. Now we moved from wave optics to ray optics. In ray optics, what you actually do, we talk about wave fronts. The normal to the wave front is called a ray. See, this is the wave front and perpendicular drawn to that wave front is called a ray. So in ray optics, we will take certain concepts and we will study about that. Okay, first and foremost, we should be very clear about the point of refractive index, right? So many questions are based on refractive index. You know what is refractive index? It's a constant. So we define refractive index, either in some books it is written as mu and some books it is written as n. Both are one and the same. So n is equal to c upon v. This is how you express in terms of velocity of light. Velocity of light in vacuum or air to velocity of light in the particular medium, either water, glass or diamond. Or using Snell's law, we can simply say sin I upon sin R, where I and R stands for angle of incidence and angle of refraction. Now, this refractive index plays a very important role. Suppose, let me say, for example, let us take a lens, okay? Yeah. Now we will take a lens, spherical lens. We are talking about, let us say, convex lens. See, I have taken a convex lens. You know, convex lens is a converging lens, but there is a condition for that. See, let us look at it. See, convex lens is made up of, now let us say, glass. Now what is the refractive index of glass? Which is 1.5 normally. Refractive index of glass. Now when we say refractive index of glass with respect to air, which we are not saying in general. So in surrounding, we say air is present. So then what will happen? When I take a ray parallel like this is the principal axis, right? The ray passing through the optical center and touching the center of curvature. Now the ray will go without deviation. If a ray parallel to the principal axis strikes the optical axis, it will come and converge at a point, and that point you call it as focus. Take another ray parallel to the principal axis, again that also will come and converge at a point on the focus, on the principal axis at the point called focus. So this is a normal case. So where the refractive index, if you say, of this material is N1 and the surrounding medium air as N2, here you can see N1 is greater than N2. I hope you understand here. N1 belongs to that of the glass and N2 belong to that of the air. So refractive index of air with respect to air is equal to 1. So 1.5 is greater than 1. So for this condition, the lens will behave as a converging lens. You understand? Now suppose if I change this little bit different. Glass is there 1.5, but the surrounding medium is not going to be air, right? I place some other medium, right? I take some other medium. Let us say the medium is something X and that is N2, okay? And let us say this, let me bring it here, that of the surrounding medium is N2. But what is the condition? N1 is lesser than N2. That means I place this lens in a surrounding medium whose refractive index is greater. That is N1, that of the lens is less than that of the surrounding medium. Suppose, or I can say, which implies, what does it imply? N2 is greater than N1. then what will happen? Then when the outer medium, the surrounding medium has higher refractive index, the same lens, let me draw again for you, the same lens, okay, I can take it this part of it. Yeah, let me draw it here. See, this is the principal axis and the surrounding medium N2, and this is N1, that of the lens we have taken. Then this convex lens will behave as a diverging lens, right? So instead of converging, this will diverge it. Yeah, and this is one of the most important concepts which you have to understand. As long as the surrounding medium is air, we say that it is converging. That is what we study in 9th and 10th standard, right? And the moment the surrounding medium has greater refractive index than that of the lens, then it will behave opposite. Instead of converging lens, it will become diverging lens. Okay? Now, let us say this medium can have 1.7. Okay, so 1.7 is greater than 1.5. So naturally, it will behave as a diverging lens. So you may ask a question. Suppose if the lens and the surrounding medium N1 and N2 are having equal refractive index, N1 and N2 have equal refractive index, then what will happen? The whole lens will just behave like a glass plate. See, the whole thing, water is there. You make a lens made up of water. Imagine, you make a lens made up of water, and if you place it inside, water and water, everywhere water, the refractive index is same, 1.33, then you will just see nothing. That means it will become like a plate. Just like that, the rays will pass straight through it. The rays will pass just like that. You know, it will have no impact at all when the condition is both the refractive indices are same. I hope you understand the concept. The same problems, I will try to do it with a concave lenses, right? We will do with concave lenses and see how the situation is going to be. Yeah, it will make you understand the concept better. Yeah. Okay, now let us take for example a concave lens. The concave lens is having a refractive index N1 made up of glass. Its value is 1.5. We know refractive index of glass with respect to air is equal to 1.5. If the surrounding medium which I am keeping, okay, the surrounding medium which I am keeping is going to be, let us say, having a refractive index something like 1.5 I have taken N1, and N2 I am going to take. Yeah, another material I am taking, right, whose refractive index is equal to let us say less than that of it, that is air. That is 1 I have taken, or even you take for example like place it in water, which is 1.33 you can say, right, water. Again you see the condition, N1 is greater than N2. Here refractive index of air is 1 and refractive index of glass with respect to air is 1.5. So refractive index of glass is greater than refractive index of air. Now what I did, I immersed it in water. In water, the refractive index is 1.33, or you also can say 4/3, and you can say this for numerical times 3/2. So what will happen? Take a principal axis, right? Now take a ray parallel to the principal axis. Then now what will happen? What usually the concave lens is going to do? The lens I have taken is concave lens. What does the concave lens do? It diverges it. Now this is 3 by 2 and this is 4 by 3. So this is n1 is greater than n2. It will do diverging because it is satisfying the nominal condition. That's okay. Now suppose if I take the surrounding medium n2 to be, let us say, 1.63. Some other material I take, right, whose value is 1.63. That means n1 is less than n2 or n2 is greater than n1. In such cases, though it is a diverging lens, what it will do the opposite, that is, it will converge it. Right? It will converge it. Let us see how it is going to be. Take the parallel rays and it will converge. You may wonder, you see, everything, because we assumed always air, air, air. We studied with the lens being in air. But the moment you change the medium in which you place, the behavior of the lens also will change. Now, you tell me the last point here, right? If the whole lens should become invisible or should behave like a plate, that means the rays should pass without deviation. Without deviation. How is it possible without deviation? That means the lens should behave like a plate. It should behave like a plate. When it behaves like a plate, that means the refractive index of the lens and the refractive index of the medium n1 is equal to n2. In such cases, there is no converging or no diverging. That will happen only there is a different refractive indices, right? And here both of them are same, and so that it will behave like a plate, right? Now, this is the concept which I wanted to teach you today. The reason being, I have seen it in the previous year papers many times. Questions are asked based on this. Okay, let me read out some of the board papers and you will get an idea on this concept. Yeah, so let me take a reference book. Yeah, so there are so many books are there. I am using one of them, and in this I have got a question from All India 2014, right? And what is this question? Let us listen carefully. A biconvex lens made up of a transparent material of refractive index 1.25. Okay, imagine, immediately visualize, draw the refractive index n1 is equal to 1.25. Yes, is immersed in water of refractive index. Refractive index of the second medium is 1.33. Now, first visualize, draw it in the rough side with pencil, a rough diagram. Your mind will become clear about what are you doing. Now, will the lens behave as a converging or diverging lens? Give reason. Look here, n1 is that of the lens and n2 is that of the medium, surrounding medium. n1 is smaller than n2 or n2 is greater than n1. We know very well refractive index of glass with respect to air, which is 1.5. That time air is the medium surrounding, which is having a less refractive index, then it will do converging. But the surrounding medium has greater refractive index, then what will happen? It will do diverging. It will behave as a diverging lens. I hope you understand. Now, what is the reason for that? Because the surrounding medium has greater refractive index than the material, that is the lens, the material of the lens. I hope you understand, right? And say the same 2014, maybe in set 2, this question has been asked. A biconvex lens is made up of a transparent material of refractive index 1.5. Yes. Further, is immersed in water of refractive index 1.33. Now look at it. N1 is greater than N2. This is a very simple case because always that is the case. Refractive index of the glass is greater than refractive index of the air. So how will it behave? Very simple. It will behave like a convex lens only. That means it will converge. It will converge because you know that the surrounding medium has a refractive index less than that of the material from which it is being made. Okay, you understand? I hope this point. Yes, you are clear about it. Yeah, practice a little bit. It's a very important concept. Then let me read one more question. That is, yes, Delhi. This is in Delhi 2012 paper which has come. Under what condition does a biconvex lens of glass having certain refractive index act as a plain glass sheet when immersed in a liquid? It should behave like a plain glass sheet when immersed in a liquid. If it is a plain glass sheet, the ray should go without converging or diverging. Yes, and what is the condition for it to be satisfied? Think what should be the condition? That of the lens refractive index should be equal to that of the surrounding medium. When N1 is equal to N2, then this will behave like a glass sheet. Yes, I move on further. I want to do two more problems. Yeah, I'll just read the problem. First, visualize. In physics, it's very important for you to visualize. The answer sheet is given to you. In the answer sheet, in the right hand side, always you can make a rough column. Yeah. See, examiners will be happy, rather they will be very happy that when you do something very clearly, mark it. Sheet is like this, horizontal, mark like this. If you want, you have time, you write rough. If not, just to make it as a rough column. Yes, we understand that. That is for the rough point. A lens behaves as a converging lens. See, it behaves as a converging lens. That means it is going to converge at the central point. Okay, yeah, converging lens in air, okay, and diverging lens in water. When I take this, yeah, you may take some time to draw, don't mind, as long as your answer is correct and you get full mark, right? It's a 2-mark question, you will get 2 out of 2. Yes, physics is a scoreable subject. You can score 70 out of 70. Yes, my students have gone so far like for 70, 68. They have secured till 68 marks, right? Just lost 2 mark. Okay, so 68, 67, 65, 60 plus is very, very, very easy if you prepare thoroughly. Yeah, so picturize first. Yeah, and now when you place it in water, the same thing is behaving like a diverging lens. It is behaving like a diverging lens. What will be the condition on the value of refractive index? This is a Delhi 2012 compartment paper. Yeah, compartment paper is very difficult. Okay, so what will happen? It's very simple. Here you just mark it N1, surrounding medium N2. N1 is greater than N2. This will become converging. And then when N1, again you mark it here clearly, N1 and surrounding medium N2. When N2 is greater than N1, it will behave like a diverging. Opposite. Same thing, if it is a concave, it will first diverge. If it is concave, the medium are going to be changing, then it will converge. So concave can converge and convex can diverge, right? So this is a very, 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 very important concept. It all depends on what is in the medium. See, there are so many other questions. All India 2010, this question has come. All India Delhi 2010 it has come, yeah, and you can prepare like this, right? More and more questions are there, right? I will come up with more problems for you in the next video, right? And you please focus on this concept for in this video, right? And if you have any problems, any doubts, please write in the comment section, right? Sir, can you answer this question, or can you solve this area? Then accordingly I will do, right? Thank you so much, and wish you all a very, 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 very happy Holi, right? The festival of colors. May you all live your life happily, with colorful life, and with happiness, joy and peace. Yeah, wish you once again a happy Holi. Thank you so much.